standing here today on the 50th anniversary since the Apollo 11 spacecraft, Neil Armstrong and Buzz Aldrin landed on the moon in that very famous spacewalk. And I'm not old enough to have been alive for when they happened, but it was without a doubt those missions that were what led me to be passionate about space. I devoured stories of mission control, of what happened, all the problem solving and so on. And basically by remembering those passions, staying true to them and following those, I found my way into the space industry. I worked in mission control for a number of years, and now I'm back in mission control. I'm very happy about that, managing human spaceflight. And so I'm going to tell you today about what the UK is doing in these lunar fields, because many, many of you will think of this. Apollo 11, American flag on the moon, the astronauts there. And of course it was an American race with the Soviet Union to get there, but there were international parts of it, and the UK played its role. And it starts with these images, if this pointer is going to work. No, it was working. We're going to go back to the old way. Some of you out in the audience will have seen these grainy images. This is Neil Armstrong and Buzz Aldrin on the surface of the moon. And it was a live television picture from the surface of the moon. Now, live television pictures then, just as today, are relayed through satellite technology. And the way that we all saw those images was through this. This is the Goonhilly 1 dish, or known as Arthur, and it's down in Cornwall. It was the first telecommunications dish built to receive messages, built to receive information that was bounced off a telecom satellite, the very first Telstar 7 in orbit, and it relayed signals from America to the UK. And it's this huge dish, very much like the Lovell Telescope out there, and it's designed to pivot, because the first telecommunication satellites orbited the Earth, as they do today, but they didn't orbit in a geostationary orbit, where they look like they stay still in the sky. That's what happens today. They actually orbited in a halo orbit, and they moved across the sky. So to track them, you had to have this big dish that was flying across. That dish has become a Grade 2 listed building, but Goonhilly is still very active, and we're going to return to this dish later. But I couldn't be here today at Jodrell Bank and not mention the Lovell Telescope. And I'm personally rather proud of this photograph because I took it myself, and it's got the telescope and the moon in it. And Jodrell played its own part in the moon. I don't want to give any credence to those theories that people didn't land on the moon. But one of the best ways of knowing that that really happened was because people saw it with their own eyes, and they saw it independently. And one of the ways that happened was that it was this telescope, the Lovell Telescope, that tracked Apollo 11 all the way to the moon. So we know that they went there. That independent verification is, of course, hugely important, because how can we believe that the Americans went there? Maybe it was all done in a stage, and it really wasn't. I'm not suggesting that it was. But that independent verification, one of them came from the Lovell Telescope. Now, excuse me, the missions were, of course, all rooted in a political race. It was a race to land on the moon, and science was not the motivating factor. But because of those missions, we did do science, and the scientists weren't going to miss that opportunity. And it's another reason why we know that those missions happened, because we have the moon rocks. This was the very first lunar sample that was photographed. And NASA, when they were doing this science, they didn't keep it all to themselves. They didn't say, well, we're just going to let the Americans do it. They, as we do now, said, no, this is an international thing, and we want to let international scientists get involved. We want the very best science done on these rocks. And so when the call went out for who was going to look at these rocks and start understanding them and finding what secrets they could unfurl, 12 UK teams were part of that, and we had 12 groups here looking at the lunar rocks. One of them is all to do with this photograph. Now, this photograph is Neil Armstrong, Buzz Aldrin, and Michael Collins, and they're in quarantine at the end of their mission. And the reason they were in quarantine was that we didn't know what the moon was made of. We didn't know what was there. We didn't know if there was life on the moon or not. And everybody was worried, or some people were worried, that when the astronauts came back, they would have picked up some bugs, some microbes, and they might be infested. They might spread some terrible lunar plague all across the world. And so they were kept in quarantine. And they couldn't come out of quarantine until we knew that those rocks didn't contain life. And one of the researchers who was looking at the rocks to see if there was life in them was Jeff Eglinton. And he was there you go, there's his passes. He worked at the University of Bristol. And part of his team was a name you might know, Colin Pillinger and James Maxwell, and here they are getting ready with a lunar sample, ready to prepare it. And it was Jeff's team who looked at these rocks and went, no, there's nothing in them. And with that, it was possible, therefore, for the astronauts to be let out and to come back and join society, and we weren't going to be struck down by this terrible lunar plague. And this is another photograph of Jeff's team. This is Colin Pillinger and Paul Abel, and they're analyzing the moon dust that had come back. And I want you to look at this picture, because what you can see here is a mass spectrometer. And you can see that it is enormous. It's huge, like the size of a room. Now, mass spectrometers we use to understand what something is made of. Very simply, and I'm not a scientist, but you use big electromagnets to bend the atoms as you fire these ions off the material. And by looking at how much they bend, you can work out what they're made of. And back in the 70s and the late 60s, this was the size of a big room. And we'll come back to that in a little while. Another one of the scientists working on the lunar missions was Grenville Turner, who I believe is on the left, with his first PhD student, Peter Cadogan. Now, Grenville was based at the University of Sheffield, and what he looked at was the age of the moon rocks. He had invented this brand new technique, a radioactive method of dating rocks called argon-argon. And he was the one who was looking at these moon rocks to understand the age of the moon. In the 1960s and 70s, we didn't know where the moon had come from. We didn't know what it was made of. And it was dating these moon rocks. And we now understand that the moon's about 4.5 billion years old. It was dating these and putting them together that led to our understanding of the lunar chronology. And it was Grenville who played a key part in that. Now, this photograph is wonderful. It says Peter Cadogan, and this came out from the UK Space Agency and Arts and Humanities Research Council's Moon Memories campaign. And I mentioned that we were collecting stories from across the UK of what people remembered about the moon landings. And we've just published a rather glorious ebook. There's at moonlandingmemories.com, and you can go there and you can see this photograph and all sorts of other things to find out more about what was going on in the time when the moon landings happened. And the other exciting thing about this particular photograph is that it's Grenville's group. And I said that Grenville was at Sheffield, but he then moved to the University of Manchester. And here we are today at Jodrell Bank, part of the University of Manchester. And that group has grown and grown and grown. And today we've got University of Manchester scientists, Catherine Joy is one of them, who look at lunar samples today. And so I strongly encourage you, if you haven't yet, to go and see the moon rocks that they've got in the University of Manchester stand out in the Starfield. Go and find out more, and you can get to Katie's talk. There was one this morning, but she's doing another one tomorrow afternoon. And they're all great. And Katie is one of 10% of all the Apollo researchers who are active today looking at these moon rocks, and 10% of them are in the UK. We have 10% of all the rocks that came back from Apollo here in the UK. So we have a thriving scientific community who are all still looking at lunar rocks. And one of the reasons that they're looking at them is because the moon is this amazing record of the solar system. I said it was 4.5 billion years old. And that's really one of the things that is why the moon is so interesting to us. Because it has no volcanoes on it. It has no tectonic plates. It has no atmosphere. It's this amazing archaeological record that doesn't change the history. All of the different areas that you can see, all of the different impacts, they've been there for hundreds, thousands, billions of years. And by looking at them, we start understanding the whole solar system. It really is a keystone to understanding what happened with Mars, with Venus, with Mercury, with the other planets, and with Earth. Because if we start understanding, for example, what happened with Venus, where the atmosphere has got hotter and hotter, or Mars, where the atmosphere has drifted away, we might start understanding what's going to happen to our own atmosphere here on Earth, and climate change and all sorts of things. It all comes back to what can we do to help us and help our understanding. The other thing I should mention about those Apollo rocks and what we're learning about science today is that we're still learning. One of the great things from the Apollo missions is that they've kept some rocks under strict control, sealed away since 1969 and the missions beyond, and they've never been touched. And only now are we starting to let some of those out to be analyzed again to see what can we learn about those rocks. Now we have bigger and better machinery. Those mass spectrometers have started to shrink. We've got new techniques, and we're learning all sorts. And we'll come back to that in a moment. But can you believe, from 1969, we landed on the moon. We didn't go to the moon again with humans from 1972, but we also didn't go with any other spacecraft from 1976, when the last Soviet mission touched down. There was nothing until 1990, when the Japanese spacecraft was the first to go towards the moon. And that sort of was the start of a new chapter of lunar exploration, and that was the first time that the European Space Agency got involved in lunar exploration. And this is the Smart 1 mission. This was Europe's first mission to the moon. It was first and foremost a technological demonstrator. It was designed really to understand about electric propulsion, which is these days a much more common, but back then a very new way of propelling spacecraft, rather than with big fiery rockets that are very powerful, but very sort of difficult, and you've got to use them in a short period of time. Instead, you can have a very gentle rocket, an electric thruster, that just puffs out ions slowly. But if you do it slowly, you get faster and faster, and that was the technology it was testing. But as it was going to the moon, we thought, well, let's do some science. Never one to miss an opportunity, and the UK had an instrument on that. And this is the instrument. It's called DKIX, and it was built in Harwell, down in Oxfordshire. And this was an X-ray spectrometer. It was designed to take the X-rays that were coming from the sun that would then bounce off the surface of the moon. And this instrument would collect them. And by doing that, you could start to do some chemical analysis of the moon and understand much more about what it was made of. The instrument also flew on a second mission to the moon called Chandrayaan-1, which was India's first mission to the moon. And the two instruments both produced some graphs like this. This was the first light, the first measurements that came on the DKIX instrument. Sadly, for different reasons, neither of them quite did the full mapping of the chemical composition that they hoped to do, but they certainly did detect different compounds, different elements on the moon. And those missions, together with that, the sort of second wave, started to show us that the moon wasn't just this barren place that we know of, wasn't just this wonderful archaeological record, but we started to understand much more about what it was made of. And what we're starting to learn is that there is water on the moon, and it's not lifeless. And this is a composite image that the European Space Agency have put together with some data at the South Pole. And this shows where we think that there is water within 1 meter from the surface of the moon. The term that you might hear is something called lunar volatiles. This is what everybody's starting to get very excited about. Volatiles are elements, are things, or compounds that in everyday life we know of as gases, or in the case of water, liquid. But if you get colder and colder and colder, they will condense, of course, and then they will become solid. And buried in the rock, down in the South Pole, where it's very dark and very cold, and the sun rarely gets into these cracks because of these craters, because of the angle of it, we are now understanding that these are collecting, and we've got solid water, we've got solid nitrogen, solid hydrogen, solid carbon dioxide trapped in the rocks down at the surface of the moon. And what everyone is starting to think and starting to wonder is, well, can we use these? Can we use them to help us with our exploration? We want to send humans back to the moon. It's always a question of resources. If you don't have to take everything that you need from Earth, well, then it gets easier. And so can we use these? And that is why there is now another sort of rush to the moon. And again, the UK is playing a role in it. And this is the Lunar 27 mission, or the Lunar Resource Mission. This is a spacecraft that's going to land on the moon in the early part of next decade, I think currently 2023. It's being built by Roscosmos, the Russian space agency, in collaboration with ESA, the European Space Agency, and it's going to go and land on the moon. And the UK has got two key roles in this. The very first is part of the landing. If you're going to land on the moon, you need to know where you're going, and you need to know what you can land on and is it safe. And this relatively innocuous-looking silver box is a LiDAR. It's going to use laser light to scan the surface of the moon to work out what it looks like. And that's being built by MDA UK, who are another company based in Harwell, here in the UK. And MDA UK are just next door in the mission control tent. They've got some models of this. You can go and talk to the engineers who are building it. You can go and learn a lot more about it than I can ever possibly explain. And so I do recommend that after the talk you go and say hello to all of them. So this box may look kind of simple and innocuous, but it is incredibly clever and intelligent, and the scanning that it does produces this sort of map. And the reason that we use laser light is because down in that south pole of the moon, it's a really harsh lighting environment. The exact reason that those lunar volatiles are there and collecting there is the same reason that it's really hard to see what's going on, and that's why you need this LiDAR. So on the way down, at 2 points, the LiDAR will scan the surface, and some other software is going to work out are there any hazards, should we be going there, hazard detection and avoidance, and work out where it's safe to land. Once we've safely landed, well, then we want to do the science. Then we want to go and start looking at these lunar volatiles. And that's where an instrument called Prospect comes in. And this is another part that the European Space Agency is providing to the mission. And this is prospecting for water. It's looking to see what water there is. The instrument is made up of 3 parts. On the left, as you look at it, is the drill. This is being made in Italy. And that's going to drill under the surface, down to a meter, where we think that water is, and it's going to bring up the rock. And then the part on the right is to me, the exciting part of it, is where we do the science. And this is the instrument called Prosper. And again, it's going to use a mass spectrometer, remember that from before, to look to understand, to see what this rock is made of. Is there water there? What kind of water is it? And it's no coincidence that I showed you that mass spectrometer photo from earlier, because this is all being done by the Open University. And Colin Pillinger, who was back then in the lunar photos that I showed you earlier, part of that team, he went to the Open University, he became a planetary scientist, and he set the group up. And it was his mass spectrometer and his group that took that huge, huge piece of equipment and shrunk it 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 till it was a tiny, tiny instrument that we could put on spacecraft. And that mass spectrometer was on the Rosetta mission that you might remember that went all the way to the comet 67P, Churyumov-Gerasimenko, I can say it, and sniffed there on the lander, on Philae, the lander, to see what was in there. It was also on the Beagle 2 lander that did land, but sadly didn't deploy the solar arrays, so we never got the science back. So all that heritage you can trace right back to the Apollo days, and now here it is in the Open University's Prospect instrument that's going to the moon in a few years. And to learn a lot more about that and a lot more about the science in much more detail than I can explain, please go and see Simeon Barber's talk, which is after mine. I think it's in the Star Pavilion, if I remembered that correctly. Go and see him, and he will tell you much more about this and the water that they are going to produce. And there you go, that's a breadboard of the instrument, the gas processing system, that's going to do all that analysis. So that huge, huge thing that was in that earlier photograph has now been shrunk down to something that's the size that you can fit on a spacecraft and on a tabletop. So the Lunar Resource Mission, the Lunar 27 mission, is one of many missions that is now heading to the moon. We are really living through a lunar gold rush age. And you can see there's lots and lots of spacecraft going. And if you can see just at the top of this slide, there's 2 words, there's institutional and there's commercial. And this is where the space industry is going now. It's really a new and exciting time because people are deciding to send commercial missions. Historically, it's been government-funded missions like the UK Space Agency deciding to build something. And now people are saying, no, we're going to provide a service. And maybe governments or other scientists or anybody who they like will buy that. And the UK is going to be a part of this too. And one of the missions that we are be a part of it is this one. This is the Lunar Pathfinder mission. And this comes back to that first big picture I showed you of the Goon Hilly dish, the Arthur dish. The Goon-Hilly company, in association with Surrey Satellites, SSTL, want to put together the Lunar Pathfinder mission. And this mission is going to go to the moon and provide the telecommunication services on the moon for all of, we hope, all of those spacecraft that are going to go there. They're going to land, they're going to need to talk back to the Earth, they're going to send all their science data back, and this is going to be one way of doing it. So these commercial telecommunication satellites in Earth that we know so much, we buy our Sky TV, we never think about it. That same model is starting to go out to the moon, and the UK is going to use its telecommunications strengths, which we are really good at here in the UK, to provide telecommunication services on the moon. And that then all gets into this. You've all heard, I'm sure, about the plans to go back to the moon and humans to the moon, and NASA want to send astronauts there by 2024. I would say that is a challenging target, but it is achievable if you put the resources behind it, which NASA are working to do. But for some time, NASA, the European Space Agency, the Canadian Space Agency, JAXA, and Roscosmos, we've all been talking about this, which is the Lunar Gateway. And this is still on the books. This is still something that we expect to see happen. This is going to be a small space station out near the moon. We have learnt over the last 20 years with the International Space Station how to live and work in low Earth orbit. 200 kilometers up above the Earth, where we are inside the safety of the Earth's magnetic field. And that Earth's magnetic field protects us from the solar wind and the cosmic radiation. It means that really, once you've figured out how to have a pressurized container that you can put your astronauts in and you have a life support system, it's relatively safe. As soon as you go out towards the moon, which is where we're going to go if we want to keep exploring, you are bombarded with the solar wind and the cosmic radiation, and we need to learn how to live and work outside the safety of that, further away from the Earth. And the Gateway is going to be the place where we start to do that. I say it's international. The spacecraft that's going to visit it is the Orion spacecraft, you can see here on the right. That's already had a test flight. There's going to be another uncrewed test flight in the coming years. And this is not just a NASA spacecraft, despite what sometimes you might think from the press. It is also being built by the European Space Agency. The service module, which is the part on the right there where you can see the 4 solar arrays sticking out, that's being built by the European Space Agency. So when it all comes together, it's going to look like this. And at the end of this year, there's a big meeting, and you'll see it in the press, called the Council of Ministers. It's where European Space Agency's member states all get together, and we all send our ministers, and we all decide what the European Space Agency is going to do and how much money it's going to have to do with it. And this is a large part of my job at the minute, is writing the business cases to put to our Treasury to make the case for why the UK should continue to play a part in exploration. It's your taxpayers' money. We don't do exploration just because it's cool, just because it's exciting. It brings good scientific and technological benefits, economic benefits back to all of us. And so if at that meeting everything goes well, and we hope it will, and Europe decides that they are going to put the funds into the Gateway, this is what we think it's going to look like at the minute. And the bits in pink, if you can see already, that's what Europe is aiming for. And here in the UK, we are hoping to provide the telecommunication services. I said before, we're really good at this in the UK. The major parts of 40% of all telecom satellites up in space come here through the UK. They're built in the UK. We are really good at this. So we are hopeful, very hopeful, that when this gets built, the telecoms will be in the UK. We're also aiming for the refueling systems. That's harder. There's a lot of competition. This is exciting new technology that is really going to revolutionize what happens up in space, where we can reuse satellites a lot more. So we're aiming for that, and we'll see what happens. Whatever happens, I am confident that there will be UK science on this, because we have such a vibrant science community who is world respected in all of these areas. So we'll see UK science experiments on board that Gateway. I'm certain of that. All of this exploration, the gateway that will allow us, I should say, the gateway that will allow us to send humans back to the moon, and we're still working out how and when, all of this, in the end, is getting towards Mars. Now, this has been the horizon goal for space agencies for decades, for years, sending humans to the red planet. It's there in a document called the Global Exploration Roadmap, which is something that the space agencies around the world write together and sign up to and say, this is where we're aiming for. And we do want to send humans to Mars, and these missions to the moon are going to be the stepping stone for that. We're going to have to learn how to exist out there, I said, in the radiation filled environment, where you can't just nip back to Earth, where you can't send regular supply ships all the time. And the moon is going to be the perfect place to learn how to do all of that. But if we're to go onto Mars, there's a huge question to answer. One of the biggest questions about Mars has always been, is there life there? And really, we need to start getting a handle on that question before we think about sending humans there. Because if there is life there, well then why should we be sending humans there to potentially go and contaminate it? But maybe if there's life there, we want to go and understand it, so we need to send humans there. So there's all sorts of questions around that. But in order to understand that answer, that question, was there life there? I want to mention this mission. This is the ExoMars rover, now known as the Rosalind Franklin rover, and this is being built in the UK as well. This is being built in Stevenage, and this European Space Agency rover is going to be the very first mission that is going to directly look for signs of life on Mars. The finishing touches are going on now. It is due to launch in July next year. It's going to land on the red planet on the 19th of March 2021. And that will start to unravel those mysteries of is there life on Mars? But if we see it there, whatever we find, well, the rover can only do so much because we can't still send all of our instruments there. Even though we've taken that mass spectrometer and shrunk it down to the size of something we can put on spacecraft, there's so much more that scientists want to do. And that's where we're hopefully at the end of this year going to see Europe and the UK commit to another really exciting mission, which is Mars sample return. This has been there in the wish list of scientists for years and years and years and years and years. We've seen with the lunar samples and with Apollo what bringing rocks back can do to help us revolutionize our understanding of a planet. And that's what we hope Mars sample return is going to do as well. It's the other big mission that is going to get decided at that Council of Ministers meeting at the end of this year. And the UK is really aiming for a big role in this mission. We're building the ExoMars Rosalind Franklin rover here. We are hoping that we will play a big part in this, something called the Sample Fetch rover. It's going to be the rover that is going to go around and collect up all the samples. It's a really complicated mission. It's, again, an international collaboration. You've got NASA, who are going to launch the rover next year in 2020 that's going to collect the samples. Some years later, then we're going to go and send, hopefully, the UK-built Fetch rover to collect them. You've then got to get the samples back to Earth, and you've got to make sure that the Mars samples never touch Earth. We do not want Earth and Mars to ever mix, not only to protect Earth from any Martian bugs, back to what we worried about in the Apollo days, but also so that we don't contaminate Mars with Earth. We want to know that what we see there is truly Martian. And so it's a really interesting technological challenge for how do you isolate the two from each other. And what you actually find out is that a lot of the tech that goes into things like isolating people from the Ebola virus come into this to keeping things isolated. So very, perhaps surprisingly, you might think, we work a lot with Public Health England to look at these things, to make sure that when the rocks come back, we keep the Earth safe. So it is a ridiculously exciting time in exploration. And all of this sort of comes back to why we do exploration. And I just wanted to show you this slide because it really is a circle. People ask, why are we going to send humans to Mars? Why are we going to send humans to the moon? Why are we going to spend money doing Mars sample return? Why do we have Tim Peake in space doing experiments? All of it, in the end, is about terrestrial benefits for all of us here. It's about science that improves our understanding of things. It's about science that improves our everyday life. The technological challenges that we have to accomplish to do all of this always bring unexpected and brilliant benefits to everybody back here on Earth. The Apollo missions led to some water sanitization, water purification that's still used today in third world countries. The ExoMars rover, is making us have to shrink scientific experiments again, scientific instruments which we can then use in labs. The technology benefits are there. We drive them forward. And we always get an economic return. From the ExoMars mission, we're seeing that for every pound invested, we get £3 to £7 back. So it's always a good investment as well. So it's all there We do it all in the end, and I hope you agree, it's your taxpayers' money, and we do it to bring benefit to everybody back on Earth. The inspiration benefits for exploration are huge. Tim Peake's mission, just in terms of education and outreach, we had 3 million children engage with that mission in 1 in 3 schools. It is always a subject that captures everybody's imagination. And so whilst I can never write a business case that just says we should explore because we should, or because we're fun, or because it is an amazingly inspirational thing that gets our young people excited about science and technology, that's always a part of it, and you put it all together, and you end up with why I think exploration is the most wonderful thing. And if you think it, well, you can be a part of it too. None of this happens without people. And what you see behind me are just some of the people who are involved in all the lunar missions that I've mentioned. Many of them are out there today. You can go and talk to them in all the different tents. The industry is growing. The space industry employs over 40,000 people, and it's growing. We need you to come and join it. If space is something that excites you, there is a role for you. You could go and be part of the scientific team that is analyzing those Mars rocks that come back. You could be one of the engineers who's building things. You could be one of the technicians who's putting the next rover together. There are so many jobs right across the industry that if you want to get involved in it, it is never too late. You're never too old or too young, and you should come and join us, and we would be delighted to have you join the team. So the moon is not just a place with an American flag on it. It is something that is international. It is something that will allow us all to benefit through our science, through our understanding, through the technology we do, and just from the inspiration of exciting everybody. So I hope next time you look up at the moon through the clouds whenever they come, you don't see those Apollo missions now as perhaps just an American achievement. You remember the lunar scientists who were there. They gave rise to an amazing planetary science community that is thriving, that's here today, and the industry that all of it is a part of is doing really, really very well, and the UK really has its own space industry and its own space agency. Thank you very much.
Okay, so I think we've got some time for a few questions. If anyone's got any questions, you want to stick your hand up and I'll come to you.
There's a hand over here, there's a few over here.
Oh, I'll get to you.
Hi there. I was wondering who, if anyone, is setting the parameters for how much any organisation can exploit the resources on the moon or any other extraterrestrial body.
That's a really good question. How much is anyone setting the parameters for these things? And it really comes back to space law. And of all the different jobs I mentioned, space lawyer is another one you can be. The UN is the body that sort of is looking at all of that and the ethics and the regulation and of how much space mining you can do. When things are scientific in nature and you're going to do the science, everyone's pretty much in agreement that that's a scientific knowledge. When it starts getting into the mining and all of these things and commercializing it, it's a whole other area, and there's discussions going on about that at the minute. So the UN are looking at it, and certainly all of the space agencies are really wanting to make sure that this is understood. And there's very much discussion still to be had in that area.
You talked about making sure that Mars isn't contaminated by Earth. Given that Viking landers have been on there for 40 years, and other items, how can we make sure that they haven't already influenced it in some way?
That's also a great question. So I'm repeating it, I think you all heard it, but how can we make sure that they didn't? There's nothing we can do now for those. They had different levels. Viking, from what I hear, got pretty well sterilized because it was basically baked through. And so that was pretty well done. One of the things that we look at today when we land in different things is where do we think there is life? We know what it takes, or we think we know what the conditions are for life. And so we can look at Mars and go, well, these are the older areas, or these are the younger areas, and this is where we think there's water. So there's different levels of protection. And we don't let spacecraft go to those really precious areas unless they really are protected. So there is nothing that we can do about the old ones. We can look at the new ones. And one of the great questions will be, if we find it, is where did it come from? One or the other. Some scientists really say if we see Martian life, it will look so different to Earth life that we will know that it was of Martian origin. It is one of those things that we will know much more about as we unravel the secrets.
Hi, Libby. So you mentioned already that the reason why we sent people to the moon, or why NASA did, was political. But now we're thinking about going to Mars. We've already sent rovers, we've already sent robots. What do you think, as the manager of the Human Exploration Program, is the benefit of sending crewed missions to Mars as opposed to just more robots?
For me, sending crew is about what they can do and their eyes. When you look at what can we do, we're already thinking about Mars sample return because we want to bring the rocks back to people here who can look at it. And that mission is going to take multiple things, and we're going to get a few small rocks back. And when you send people, you can see things, you can see what's going on, you sort of look at it in a different way. When the Apollo astronauts went, they were able to sort of pick out the one rock that they went, that one looks different. I don't know why, but based on what I can see and I can intuit, and that's the one I want. And there's this Genesis rock that came back, and they said that really unraveled a lot of secrets of the moon. There's a great debate there. When we do go back, it will be to the moon, or when we go on to Mars, it will be rovers and humans working in tandem. And we won't do things unless it makes sense. It's too expensive just to do it because you're doing it, in my opinion. But I think that humans do add something that rovers can't. There's a question at the back somewhere. There's waving going on.
I know that there's a spaceport being built. How long do you think it will take for humans traveling in space to become normal?
That's a lovely question. We are building spaceports here in the UK. We've put down the legislation. There's some being in Scotland, there's some down in Cornwall. And we are entering a time now where commercial spaceflight for people is on the horizon. Richard Branson, who is behind Virgin Galactic, was hoping that perhaps this weekend he might finally fly in his spacecraft into space for 6 minutes of weightlessness. NASA have now been paying Boeing and SpaceX to build spacecraft that they will run as commercial services. So NASA, rather than buying a spacecraft, as they did with Apollo from industry, they'll say, we want to buy a ticket, and industry, you run it. And those tickets are going to be available on the open market. So at the minute, you need to be pretty well off to go to the International Space Station. I think it's about $45,000 a night they put down, but you've got to get there. It's a few million to get there and back. But if you've got that money, you can. So how long until I think it becomes normal? I think, I can't see you, but it sounded like a relatively young voice. I think in your lifetime, it will be. And I say this to young people now, and I believe it. If you start saving, in your lifetime, you will be able to go to space. When I was young and I was your age, I would look up and I would see Concorde fly over. And I had a dream when I was 9 or 10 that one day I might fly on Concorde. And Concorde, sadly, is no more. But the tickets, whilst being very expensive, was something that if you chose to, and if you've worked hard and you put your savings in and you decided that that was what you wanted to do, you could afford to buy a ticket on Concorde if you saved for it. And I think you'll be able to do the same. You might not be able to go all the way to the International Space Station, but you'll be able to go to space just for a few minutes on a suborbital ride.
So with all of these, with this like Cambrian explosion of like new space projects within like LEO, lunar, all this kind of thing, on that same point, should we just be really accelerationist about it and just make the metric number of people in space?
So make
the metric number of people in space.
I can't understand. What's the question? So make the what?
Should we make the metric?
The metric. Oh, the number of people in space. Should that be how many people are going? Well, in some ways it already is. Everybody counts the number of people in space. It's been 550 or so. What do I think about that? I think it's not just about from a government perspective, sending people into space. We are have to decide, different priorities. What are we going to spend the taxpayers' money on? And to just put people there, for me, it isn't enough. We've got to have more of these things. But the commercial return that's happening, that will be really what drives them, because that will equate to ticket sales. So I don't think it should just be that, but I do think that we will see that number start to increase, and I know we will, because we're going to start seeing more people on the International Space Station, so the flight rate's going to creep up anyway. But I think there's more to it than that.
Kennedy said in '62 that I'm here.
Thank you.
Kennedy said in '62 that would be the decade that man would be on the moon, and he made it in '69. Should we not be a little bit ashamed that now, 50 years later, we've not managed to progress beyond that in terms of getting man out anywhere?
I'm going to say humans out there, first of all. To me, it's all about humans.
Human is what I meant. Absolutely.
It's, thank you. We have progressed. I still find it amazing that we went from no humans in space to humans on the moon in 8 years, and I've been working at the Space Agency 5 years. And times have changed, but the amount of money that went in those 8 years, it was something like 15% of the GDP or the federal budget, and I'll get that statistic wrong, but it was a lot of money. And we haven't done nothing. We've built the International Space Station. We've learned how to live and work in space. We've had humans in orbit every day since 2000. And so we've done things, but we've done them in a more sustainable, more affordable way that has been building the blocks to now where we're saying, well, we've got low Earth orbit done, sorted. We need to keep that. It's one of the reasons commercialization is so important. We need to keep that facility. But the government funding and the governments are saying, well, so let's push out and explore more and get those benefits of science and technology and inspiration that come with it. So I think we've done wonderful things since then. We've just changed the tack of doing it, and we're doing it not in a race, prove I'm better than you way, but we've done it in a collaborative, working together way, and space should be collaborative. Okay, hi.
Why do people put flags on the moon?
Why do we put flags on the moon? That's a great question. And I think that comes back to what I was just talking about. When you remember what drove Apollo, it was about America proving that they were better than the Soviet Union. And so they wanted to say it was America that did it. But there was something about that mission that even those who did it, even the astronauts, Neil and Buzz and Michael and the rest who followed, they knew it was not just about America. That moment, and we saw it in the Moon Memories campaign that we did at the Space Agency, was an amazing time, and people all around the world understood it. We've had people, stories of people who woke up their children who would, 1 and 3, I think, they were not going to be old enough to remember this, but the parents said, we want to be able to tell you when you grow up that you saw this. You may not remember it, but you saw it. Everybody went out and bought televisions. The world stopped. We all remember where we were. And so even though there was a flag there, everyone understood that it was humans and humanity who had done this. So it was America proving the Soviets right, but that flag is now long gone, and the UV light has made it disintegrate. And what's there is the footsteps and the technology that was there. So it's about much more than just the flag. Yes.
You said you don't want to contaminate Mars. So what's your opinion on terraforming and colonizing Mars?
That's a very good question, and it comes back to there's an awful lot of debate to have. I think we are a long way off doing that, first of all. So I think we've got a lot of time still to have that discussion and that debate. My view, and I will be very clear, this is my view, not my space agency view, is that we need to think very carefully about doing that. We've got a planet here that we are struggling to understand how to deal with. And before we start terraforming and colonizing it, then I think we need to work out on our own planet first. But that said, if in years to come we've sorted out technology and we've sorted out funding, and it comes back to reason, it comes back to economic cases why we should be permanently living on Mars, then I hope that the people who do that take what we've learned from Mars and do it in a sustainable and considered way.
Okay, I think that's all we've got time for questions, but thank you very much for coming for the chat. Thank you, everyone.
Thank you very much, everybody. Thank you. Have a great day. Thank you.